Hi, everybody. I'm Bryce Taira. I'm representing Valortrac. What we're doing here is we're building UAV sensors to detect unseen pathogens or bacteria that might occur in crops and also in livestock. And one of the main reasons, before I go into the tech, that we're looking at this is because right now with current methods today, whether it's PCR or Petri type of testing, currently you have to have like a 24-hour, maybe even a 48-hour turnaround, which takes a long time. So the goal is to basically pair against hyperspectral imaging to basically identify the problem while we also use a drone to actually use this technology to actually take the sample. So what you're seeing here is it's a surface enhanced Raman spectrometer. These are somewhat big, but I do have a line to a manufacturer that makes one that's less than a quarter of a pound to be accessed and to keep the weight of the payload on the drone less than 5 pounds. So the way it works is whether it's air, water, or some material, we basically use this spectrometer and it produces a laser that images or basically shoots against a gold nanoparticle that basically when it changes color, as you can see on the right there where you see kind of like the wavelengths there, that's basically fingerprinting what you see as the pathogen or bacteria. So that's kind of how it works. And, kind of moving on from that, it's a proven technology. It's already in biomedical space. It's in environmental monitoring. It's in food safety. And I come from the food safety and compliance background. I also work with a lot of different commercial insurance companies in my prior life. And this is kind of the area we're looking to extend that capability to. So crop health monitoring, livestock monitoring, soil analysis. This one is pretty particular. I know a lot of people kind of talked about this today. Also in any kind of pesticide residue that might come off from, come off from any kind of pesticides used in the crops and field, and also to get yield optimization is ultimate goal. So this is kind of what we're thinking. Maybe the mock-up might be, I know it's an AI generated picture, but what it is we'll be having like the sensor attached to a winch where we'll be able to actually come down to the surface, take that type of sample, and it's all driven directly through mobile applications. So it's very easy to use. One of the things that has not been done yet, though, is to take the sample directly from the air, which we are going to be looking at and building a new type of device that's additive to this, but still making the payload less than 5 pounds. So it's capable to fit on the majority of the drones that actually are currently being used in farming technology today. And these are the specifications that we hope to stay with, which is basically pathogen detection time, basically detect it in under 15 minutes instead of waiting for a PCR turnaround 24, 48 hours. Also to have the drone flight time around an hour, maybe 45 minutes. And then also to have the mobile integration application. And that could feed in, the hope and goal is I work primarily in systems integration. So the hope and goal is you can patch it into your ERP or all of these kind of things, work with a lot of major CPG manufacturing companies. And I think that this is basically the way where we can develop that kind of going further. And if you know anything about not just food waste, but also any kind of food safety or product recalls, by the time it actually happens, the food's already out there. So the goal is to get an early detection, not to get 100% detection, but early detection. And these are some of the areas of market opportunity. Again, really, the food safety compliance is really near and dear to me. That's kind of why I got into this. And the size of the market, it's pretty big, especially from the UAV technology now being used in agriculture, ag tech, clean tech. But also, we're looking at just the Southern California market, which is around 15.4 million. And this is kind of the reasons why now a lot of more regulatory and the environment concurrently. Also, different investment trends are kind of trending in this way as drone and different type of new technologies coming out today, where people are spending a lot of money to basically raise up different type of startups. So this is kind of where we have our advantage. We have a reusable process. It's reconfigurable. Multi-sensing, it can sense multi pathogens and bacteria and also different elements in the air at the same time. And also it's an immediate identification. And here's a couple of top competitors currently in the market now. And this is kind of our mission. We want to basically take something that's off the shelf and then build up to different type of capabilities as we add on to that. And also the other thing we're doing is going to be adding on an AI ML backend that basically gives a step-by-step process to the farmer or to someone who's caring for the livestock to basically manage their process. And this is our team here. I'm a recent grad from USC out of the MBA program. That's where I met these guys. So myself, I'm primarily in food and beverage manufacturing. Tim is our veteran lead. So we're a service disabled veteran-owned firm. And he also helps me to get non-dilutive funding, call it NIH, call it DOD, whatever you might think of. And Shuren, he spent his whole time in his PhD in photonics, which is the current technology we're working on. And currently, he's also looking to partner that with a LiDAR system, specifically with hyperspatial. And we're looking to raise about $1 million. This is kind of like where we're seeing spreading that across 18 months worth of materials, lab services, and so on. And yeah, that's kind of it. So thank you.
So Bryce, how are you going to price this product?
Yeah,
is it
great question. Yeah, so my model right now for the business model is to basically price it along with people who are already manufacturing the product. So the sensor company I mentioned earlier is in San Jose, and we have an agreement where we're going to be working together and developing the product together and selling the service and also any other co-created applications together for this particular product. Yeah.
How much would that be, like, per acre? You're going to charge something like, and what would be an estimated pricing on that?
So the sensors are pretty expensive. They're roughly somewhere in the $15,000 to $30,000 range for this particular sensor. Currently, right now, because they're made in low quantity, that's kind of where the scaling hasn't really taken place. But our goal is really to scale that up where we can get it down maybe in the 10,000 range, and also add on this application and service as part of a subscription package.
Yeah, I mean, I've looked at your competitors. Are they really your competitors? Because they don't offer the level of scale.
They don't. They're currently in the space where they take different. So kind of like what we heard earlier, where you can send in your samples and basically they turn around and give you your result within about a 24, 48-hour turnaround. But the problem with that is they have, I'll say this, they're more of my competitors because they have captured most of the customers out there until maybe a new technology like this is vetted and proven.
Yeah, one other follow-up question is that in terms of when you are doing the scanning, right? Mm-hmm. Will you have the ability to go down into the canopy? Because some of the disease, as it progresses, it may not be, at the aerial, I mean, like aerial chart, some of them are root bone or whatever, right? So how would you basically overcome those sort of limitations?
So we have a set of tests that we're going to be running where it's basically capturing from, like I was mentioning, the water, land, and also air sampling, and then to determine what the range of sensitivity is before we actually go and modify the sensor for this capability. So originally this came out because I was working on an application, specifically this, where it was built for the Department of Defense. Specifically, we're working with USC's Institute of Creative Technologies to detect chemical warfare from the air, to understand that data point. So that's on one side, we're doing that. And on the other side, we're working towards agriculture and clean tech. So that's kind of what we're doing now. So, I have like 20 seconds left, but is there any other questions?
Hey, Bryce, I just might have missed this, but are you actually deploying the drones and flying them, or are you handing them to a service provider, or
Yeah,
who's
so
doing the work?
USC actually has a drone project, and we're also in talks with Cal State Long Beach as well for a rover project as well.
No, I mean,
they have
and when you're in market, how does this get deployed or implemented?
So right. So for that specifically, yeah, I'm not exactly sure who would be the specific operators for that just yet, to your point. But currently right now, we have drone operators that have signed on with us to basically do all of the testing. That might be something future I'll be looking at to develop. Yeah. Awesome. Thank you guys.